All right, our next speaker is from Malvern Prep in Pennsylvania. His talk is entitled, Who's Afraid of Greyback Beetles? Please welcome Christian Talbot.
So let's start with a little thought experiment. If NASA came to you and asked you to design the first school on Mars, how many of your faculty and staff would be prepared for that challenge? How many would be even interested in that challenge? How many would say, no thanks, we're good? When faced with major challenges, many organizations will use a re-engineering model. I want to illustrate what that looks like by telling you a story from about 80 years ago when greyback beetles threatened to decimate the Australian sugarcane industry. So in the 1930s, Australia suffered a devastating infestation of greyback beetles. When Australian officials learned that the Hawaiian cane toad is a natural predator of the greyback beetle, they did what seemed to be the obvious thing. They imported 102 cane toads. Well, it just so happens that when put into a new ecosystem, cane toads behave very differently. For one thing, they started to reproduce exponentially. For another thing, they would eat anything in their path, including their own young. So what started out as a bioengineering solution quickly became a disaster. I learned about this story in Stanley McChrystal's Team of Teams, and you may be wondering, what does this have to do with designing a school on Mars? Well, McChrystal offers a very different model for solving challenges like these. And it basically boils down to the difference between complicated and complex. Complicated situations may have many moving parts, but they're ultimately predictable. Think of like the combustion engine. Complex problems, on the other hand, have many interdependent parts, and that makes them fundamentally unpredictable. Australia was dealing with a complex problem. Here's a more personal example. When I arrived at Malvern Prep 5 years ago, I inherited a strategic plan with 7 goals, 22 strategies, and 400 tactical items. Classic re-engineering project. And one thing we needed to transform was the compensation model in order to attract and retain the best talent. First thing we did was diagnose the fact that the existing compensation model allowed people to individually negotiate salaries. So we figured, well, we can fix that. We'll engineer a solution. And we decided we would create a transparent salary benchmarking model to establish equity, to attract and retain great talent, and to boost morale. Well, we did establish equity, and we did attract great talent, but morale went down at first. Why? Well, we were trying to solve a complex problem, a culture of individualism, with a merely complicated solution. We had unleashed some cane toads. The Buddhist nun Pema Chodron has said that nothing ever goes away until it has taught us what we need to know. And in that spirit, we kept plowing ahead with an org redesign and a new feedback and observation protocol and other re-engineering efforts. Would it shock you to learn that we encountered the same cultural resistance over and over? We kept seeing greyback beetles everywhere. And so we kept unleashing our cane toads on those greyback beetles. And when you try to solve a complex problem with a merely complicated solution, you should be prepared for some messiness. So, one more time. Nothing ever goes away until it has taught us what we need to know. And just in case you're wondering, yes, sometimes I felt like and even looked like the kid in this picture. Instead of recognizing that our challenges were an expression of our cultural DNA, we had mistakenly thought of Malvern Prep as a machine. Machines are complicated, but they're predictable. An org redesign, a compensation model, these may seem as though they are parts of a machine that can be re-engineered, but really our challenges were genetic, expressions of a cultural DNA. So rather than a machine, a better mental model for the challenges facing our independent schools would be the organism or the ecosystem. Some of you might even be thinking of the virus, so no judgments there. This light bulb at Malvern Prep went off for us when we started to think in terms of teams. And over the last 3 years, we have used teacher teams in our summer institute, in our entire middle school and part of our upper school, and also in our leadership structure. And the results have been extremely positive, though not without pain. Teachers who have not been on teams, they've worried, well, what does this mean for me? Teachers who have been on teams, though, have had a personal experience of solving complex challenges. Can this help us prepare students for a future that is fundamentally complex, a future in which virtual reality will sometimes displace physical reality? That future's here already, by the way. This is a picture from NASA's Jet Propulsion Lab. Can one class or one teacher really tackle that challenge? Or consider a recent study from Oxford University that determined that in the next 20 years, robots will replace 50% of U.S. jobs. Is that a merely complicated challenge that we can solve by engineering the curriculum? What if instead we adopted a base camp mindset? What if we focused on designing and nurturing cultures of adaptive teaming? What if our schools could be teams of teams ready to evolve and adapt for the most complex challenges? Maybe even design School for Mars. And while I know that carbon-based life forms can't survive direct exposure to the Martian atmosphere, just in case, something deep down inside tells me that when we colonize that planet, we probably shouldn't bring any cane toads with us. Thank you.
Thanks, Christian.